If you fly FPV, I'm sure you're aware of the Insta360 GO, which was designed to be like a 1-minute video recording kind of HD camera, stabilized, that you can wear on your body. The Insta360 upgraded it so the FPV people could get 5 minutes of recording. One of the issues is it gets pretty hot running for 5 minutes on its own, and if you don't cool it down, the subsequent recording won't be the full 5 minutes. It could actually be as short as a minute. And that's so what we need to do is to figure out how much cool time we need between flights to allow this to give us a reliable 5 minutes for each time we use it. Now, it holds about 70 gigabytes. My testing has shown I can get about 4 5-minute files on there if I allow it to cool down to the original temperature before I try to use it again. So the trick was to figure out how much time we need to cool down, and is there some techniques we can use to cool it down faster so that it can get back in the air again. So the first thing that I did is I just let it run on the bench here, and I measured the temperature. It turns out the middle of the back is the hottest point, so that's what I used as the standard measurement point. Took data during the recording process, what the temperature rose to, and then just sitting here after the recording's done, measuring the temperature as it cooled off. I then did the same thing using a fan, something like this, where I would cool it down afterwards, or I would cool it as it's recording and collecting that data. Again, I was hunting for a combination of cooling methods to be able to cool down quicker, to get us back in the air more quickly. I also did do a bunch of flights with it mounted and measuring the temperature. I'd land at about the 4.5 minute mark and then take a temperature reading to see what it was at the end of flying compared to what it would be if it was just sitting on the bench. And then both letting it cool itself sitting in the mount, as well as pulling it out and cooling it either mainly with a fan, and collected that data. So I charted all that out. Let me share with you what I got. Alright, the first set of data I'll show you here, if you look on the blue line here, that is just the static 360 GO temperature profile as it's recording in the first 5 minutes, so the first 300 seconds, reaching a peak of about 115 degrees Fahrenheit before it'll shut off. And then I just continued to measure the temperature, and it actually, to get back down to about where it started, about 77 degrees Fahrenheit, it took a full 15 minutes. And then I repeated this several times, so I was able to start it again, run it all the way up, and then get the full 5 minutes. I did this a number of times so that the 15-minute cool down period seems to be the safe time for it to cool down by itself from this starting temperature. Now, it may vary a little bit if you're starting at a higher temperature to begin with. You may have to, you're going to end up with different data, basically. The next thing I plotted on this chart here is I also did it by measuring it as I was flying outside, took a starting temperature, and then I landed at about the 4:30 mark after the recording started, took a series of measurements after that, and because I wasn't getting any airflow, it started to rise up in temperature again. In this case, it went up to about 102 degrees Fahrenheit, even though it had been being cooled off while flying. But it seemed like its cool down period was about the same profile as when it was on its own. This next chart shows basically the same profile in the blue of it heating up while recording for the 5 minutes, and then after the 5 minutes the outside case will still continue to rise for a little bit, maybe 45 seconds, And then I did place the camera in that airflow from that fan about 6 inches away, and it took 6.5 minutes for it to cool down to about the starting temperature, and that was the safe number where I could start it again, repeat it, and I'd get the full 5 minutes. I was able to do that quite a few times. So 6.5 minutes cool down using a fan, in my case, to get it back down to the 75 degrees starting temperature. Again, if you're using a starting temperature that's higher than that, your results will be a little bit different, but this will give you a general idea. Now, one interesting thing was I recorded it while connected to the airflow of the fan, and it didn't rise to as high of a temperature, which makes sense. But after it stopped recording, the cooling down while it was mounted on the quad, so it's protected by that printed mount, it didn't cool down as quickly as it did if it was just out of its mount. So that's something to think about when you're coming up with your own cooling strategy. It looks like it's better to take the Go out of its mount to cool it down, either with a fan or some other method. Now, if you're looking to really cool it down quickly, what I found works well is to put the Go in a little plastic bag, put it in a cup of room temperature water, and within 2 minutes it'll be down to its starting temperature. So this is one way you can get the temperature down to the point where you can start to reinstall it and start another flight with the Go back down to a good starting temperature, and you get repeated 5-minute flights after that. So I hope this was helpful. Have a good day.